All right, so in this video, we're going to talk about calculating residuals and creating residual plots. This is going to be useful to help us analyze how good a line fits or if a line is even the right shape for a scatter plot. So let's take a look. So a residual is the difference between the predicted y value from a trend line and the actual y value found in a scatter plot. Essentially, it tells us how much above or below average a data point is. So for instance, if I were to look at this data point, I can see that the actual y value was 1, 2, 3, 4, 5, 6, 7, 8. So my actual y value here was 8. But according to my trend line, for the same x value, which is 2, the model predicted that it should have a y value of 4. So if I were to calculate the residual, I would take what I actually had. And so what I actually had was 8 for my y coordinate. And I would take my predicted value, which was 4, and I would subtract those two. So the residual would be 4. 8 minus 4 is 4. And so what that tells me is this data point is 4 above average, which we can see this point was clearly above average compared to the average trend line. Over here, on the other hand, this had an actual value of 3. So the actual y value there was 3, whereas the predicted y value for the x value of 4 rather, was 5. So the predicted value was 5. So if I subtract that, 3 minus 5 gives me a residual of -2. So that tells me that this point was 2 below average since it was negative. What do you think the residual here would be? So the residual here, we can even just count, is 1 because we are 1 above average. And we would get that by doing 1, 2, 3, 4, 5, 6, 7, 8, the actual value 8, minus the predicted value of 7 to get a residual of 1. So we can create a residual table for our data, which will then help us make a residual plot. So to create a residual table, we're first going to calculate the predicted value of y using our trend line. So this is the equation of the trend line we saw in blue on the last screen. And then these are the actual data points used in that scatter plot. So what we're going to do is we're going to use our Desmos calculator to plug the actual x value into our trend line equation for x. So we're going to start by doing 0.5 times 1 plus 3. And so the predicted y value for this data point is 0.5. Now we're going to plug in 2 for x, and Desmos is really nice because we can just backspace and change it to a 2 to get a predicted y value of 4. When x was 4, our trend line equation predicted that y should be 5. When x was 6, our trend line predicted that y should also be 6. And when x was 8, our trend line predicted that y should have been 7. So we calculated the predicted y value, and now we're going to subtract the actual y value minus the predicted y value. So we always want to do actual minus predicted. So I'm going to do 2 minus 3.5, which is going to give me negative 1.5. I'm going to do 8 minus 4, which is going to give me 4. I'm going to do 3 minus 5, which is going to be negative 2. I'm going to do 7 minus 6, which is going to give me 1. And I'm going to do 8 minus 7, which is going to give me 1. So these are all my residual values. We've calculated these ones from the actual scatter plot. So we came up with the same values that correspond with it. So we're going to now take our X values, and we're going to plot them with our residual values. That's going to give us our residual plot. So this is going to go on the x-axis. This is going to go on the y-axis. So on my x-axis, I need to go up to 8. So I'm going to count by 2s. So this is going to be 2, 4, 6, 8. And then on this is going to be my residual values. And so my highest residual was 3. So I'm going to go up by 1s. 1, 2, 3, 4, and -1, -2, -3, and -4. So for this scatter plot, my X value is the one from my data. So we had 1, 2, 4, 6, and 8. And then my Y value are actually my residual values that I just calculated. So let's look back and see what we got. We got -1.5, 4, -2, 1, and 1. So -1.5, 4, -2, 1, and 1. So we're going to plot 1, -1.5. So 1, -1.5 is going to be right about there. 2, 4, 4, -2, 6, 1, 8, 1. And so you're probably looking at this saying, I don't see much of a pattern. It's not a straight line like my scatter plot was, but that's actually good. A random residual plot tells us a line was a good fit. Because essentially the x-axis serves as that blue line that represented our trend line. So if we draw a good trend line, some of the points are going to be above average, some are going to be below, and it's going to kind of randomly happen throughout. So random is a good thing. If you were to get a pattern, if it were to go up and come back down, that actually tells us that a trend line wasn't a good shape for the data. So that is how we create residual plots from some trend line data.